All right, let's get started. Um, Everyone, we appreciate you joining us for this webinar and talking about the frontier, navigating the frontier of AI. A little bit of background. So my name is Aaron Call, and I'm the founding principal at a consulting firm called Jaunt. And we focus on helping executives and investors evaluate and strategize for future market opportunities. And I think one of the biggest market opportunities we have at this day and age is AI. It's a huge buzz. Everyone's talking about it. There's a lot going on with it. And what we're seeing is a lot of executives are not fully understanding the nuances of AI and where it's headed and how to strategize for it. And so I've invited a couple of friends of mine, Tim and Stephen at Synaptiq, and they are the gurus of AI from my perspective. And so I look forward to learning from them and unpacking this AI and how we can strategize it better, strategize for it better within healthcare. So Tim and Stephen, thank you for joining us.
Thanks for inviting us, Aaron. Excited.
Thanks.
Good. Well, I give myself a little bit of an introduction. Love to have you guys introduce yourself for our audience, and tell us a little bit about the lens that you're looking through and how you got into AI and what you're doing at Synaptiq.
So maybe I'll start out. My name is Tim Oates. I am the chief data scientist and co-founder at Synaptiq. I am an academic, so I got a PhD back in 2001 doing AI and machine learning. Actually, for my thesis, was looking at computational models of language learning on robots. I started grad school in '93, so I've been doing AI professionally for 30 years, which is why I've got the gray hair. Stephen and I started Synaptiq how long ago now?
That would be eight going on 9 years.
Eight or 9 years ago. And so what I sort of like to think I do reasonably well is, since I'm a professor and a researcher, I advise graduate students and write grants and papers. I sort of know the latest and greatest in AI, but in the context of Synaptiq, I try and apply that in ways that benefit customers.
Great. So, hi, everybody. My name is Stephen Scleroux. I'm the CEO of Synaptiq. I've been in the software product space for about 27 years now. I've been in and out of big companies and startups. I actually have a biology background. And so for the first time in my career, spending a lot of time in a biology-related field, healthcare, and having a lot of fun doing it. So Tim has taught me everything I know about AI. We met back in 2010. We worked together in another startup. And over the course of the 9+ years we've been doing this together, I'm kind of more the product and the strategy guy, and I've been absorbing everything I can on technology and what's going on in the AI space to stay up to date. It's been very exciting.
Wonderful. Well, thank you guys, and thank you again for taking the time to enlighten us about AI and how we can best strategize for it. And so a quick agenda for the rest of the audience. We're going to start with Tim and Stephen really diving into the weeds of AI and how it works, kind of the functionality behind it. So we're all starting from the same baseline for a conversation following. And then we'll get into a discussion of applying that AI in healthcare. How do we best do that for medical technologies, for health technologies? And so we'll have a good discussion there. And then towards the end, we left a little bit of extra space for the audience to ask questions. And so please feel free throughout our conversations, throughout their presentation, to throw some questions into the Q&A box down there at the bottom. And we'll do our best to get to them either throughout the discussion or towards the end. So with that, let's start with this baseline. Stephen and Tim present and teach about AI quite a bit. And so they're going to start with that for us so that we have this a little bit of baseline.
Okay, can you see my slides?
I see it, yep.
Okay, so I've just got 6 or 7 slides, and I'm going to do a whirlwind tour of AI, machine learning, what are they? Strengths, weaknesses, where are we going as a field? It's important to start out talking about data. One of the reasons that AI and machine learning are so powerful these days is because we've got large volumes of data. There's this great old paper that was written back in the 90s, I think, and the title of it was The Unreasonable Effectiveness of Data. And basically what it showed was if you don't have a lot of data, there are big differences in machine learning algorithms in terms of how they perform. But once you have a ton of data, those differences disappear. So really, there was a tremendous amount of power in data. You can have structured data, SQL data that sits in a database. You can have text, which are, unstructured documents, or XML, spreadsheets, videos. One thing that the field as a whole is doing really well these days is being able to integrate those different kinds of data and let the different kinds of data inform what the AI and machine learning systems are doing. So, okay. And then there's like these terms that get thrown around. So artificial intelligence is this sort of general umbrella. And when I first came into the field in the early 90s, there was AI, which was, we're trying to understand how do you computationally realize the kinds of things that humans do cognitively. And machine learning was a small chunk of that. Turns out that over the years, what happened is that as people discovered the power of data and we got access to lots of compute, we realized that just trying to be smart and code algorithms that do things like reasoning and planning, it's really hard. But if you throw a bunch of data at it, you can solve the same problems. You don't have to think as hard. The machine has to work really hard, but that's okay because we got lots of compute. So machine learning is the study of how do you build computer programs that get better at some task with experience. And then the other term that you hear all these days is deep learning. And so deep learning is just machine learning models, which are neural networks, which basically build lots of different layers of representation. So, and the important thing is that they learn those layers of representation. So interestingly, when you hear about AI these days in the popular press, they're really talking about machine learning, and really what they're talking about is deep learning. So all the advances that you're hearing about these days are deep learning methods applied to tons of data, and it's basically taken over. So really, these bubbles should be, there's this giant deep learning bubble. There's a little bit of a rim of machine learning left and a little bit of a rim of artificial intelligence that's left. So, lots of elements of that. There are statistics and data engineering. You'll hear terms like predictive analytics, machine vision, large language models, sentiment analysis, and robotic process automation. So all of these things are occupying different areas within this space. In machine learning, there are kind of three different types of learning. One is supervised, where you've got a data set where you've got a thing that you want to know something about and the correct answer. So you can think about documents, and they're labeled by humans as to whether they're a particular type of form, or is this a movie review that has positive or negative sentiment. And so the machine learning system is trying to mimic, if I see a new thing, can I give the label that the human would give? Unsupervised learning is where you just get the things. There are no labels. So in medicine, it's very common, for example, to take patients and cluster them into cohorts. And you would like to believe that those clusters correspond to groups of people that go through the same health states or the same trajectories as they're receiving treatment. And then reinforcement learning has really come into ascendancy lately. So anytime you see any reports about systems that are playing video games at superhuman level, that's reinforcement learning with lots of real interesting applications. So the timeline that's happened, it's really interesting, right? So AI was invented sort of in the 1950s. In the 90s, people started thinking about business intelligence, and you saw some applications. In the 2000s, you get these very large companies that, like Google, Facebook, that have access to tremendous amounts of data and compute, and they're able to leverage that to be able to do interesting things with AI. Then you get in the 2010s, massive storage, more compute becoming available. So EC2 is out there, and everybody, if they have enough money, can pay to get lots and lots of compute. Then in kind of 2015, you get these early adopters that are starting to use artificial intelligence. And then in 2023, actually sort of ChatGPT comes around. There was some groundwork that was being laid for that a couple of years prior to that. And then everything changes, right? So large language models basically anybody with an internet connection can go talk to this thing, which is a computer program that really is like talking to a human, and people just see all kinds of possibilities there. So, what's going to happen next? So what we're seeing now in like 2023 is you get ChatGPT 3.5 and then 4.0, and then Facebook comes out with a model. So everybody's coming out with a model. You get these bigger, more powerful models. And so what we've learned in machine learning, you got to have a lot of data, you got to have a lot of compute. And the bigger the model is, and we can talk about what it means to have a big model, the more powerful it is. But then you also get people who say, well, that model's that's awesome. That's a great model, but it's too big. I can't run it on my desktop. So people will start trying to squeeze them down, right? You get these sort of leaner, powerful models, and Llama is a version of that. And then you get language models applied to all kinds of different applications. I think moving forward, what's going to happen is that the language models are going to be able to condition their output, right? So right now you type something to a language model and it says, here's something interesting that I'm going to say to you, but it doesn't have memory for things that you said yesterday or last week or last month. I think we're going to see that sort of broader context that the language models have access to, and then being able to tune them for individuals or companies. We're seeing more of that happening. And then I think sort of beyond that, one thing I hope we have time to talk about is one of the limitations of these models is they're just gabbing, right? So they're in very interesting ways, right? But they're just talking. They don't have any sort of internal world where they're doing reasoning and representing things the way you and I do. And I think that's going to be a key area for innovation. Also, very important to be aware that, AI systems and machine learning systems, they're only as good as the data that they're based on. So, there's a lot of garbage on the internet. So you got to be careful of sort of what's being used to train these models. Also the case, there's been a lot of news about biases, that data that are created by people are used to train these models. And so biases in human generated data are going to find their way into these models, and they're inscrutable, right? So these models have 100 billion parameters. So there's 100 billion real numbers in there that control what the model does. How do you understand what's going on? And it is always the case, at least these days, it is always the case that human plus an AI partner is often better than a human alone, but the human alone is way better than the AI by itself. So you don't really want to hand any really important task completely over to an AI system these days. So Stephen, I'll hand it over to you.
Yeah, thanks, Tim. So Tim kind of mentioned this at the beginning of his talk, data. And, one of the key points that we've, realized over the last 9 years is there really is no AI without data. And so what we've been focusing on with our clients is coming up with ways for them to figure out how to build a strategy that is realistic in their organization and allows them to take advantage of their data. So if you move to the next slide, we call that AIQ, by the way. So I'm just going to go through a series of slides here that talk about a framework that we've come up with to think about strategy. And this can be applied to a startup company. This can be applied to a due diligence effort. This can be applied to very large companies, which we've gone through several times now. So first of all, at the center of all data strategy and AI strategy is the organization, right? So thinking about strategy itself is a very key requirement to have a strategy, right? So you need to have a strategy and leadership at the center of that. You need to think about the people and the culture in the organization, the roles and the responsibilities, the organizational structure around data, as well as think about the architecture, the systems you have, and how the data flows through those systems, and the governance of that data that you're collecting. Super critical. So this organizational foundation is really the center of an AI strategy. If you move to the next slide, Tim, thank you. One of the things that we've learned over the last 5-6 years of delivering data strategy services is that many companies are thinking about their data as an asset. And if they're not, they need to be thinking about their data as an asset. And one of the best mechanisms that I've seen in my career of thinking about things as assets is really to compartmentalize them into products. And for those of you on the call that have been involved in products, you know that it's a very broad discipline ranging from marketing to working with engineering to bringing things to market. And so what we've found is that outside that organizational center or nucleus of this process is really product management and user experience. And user experience, typically isn't tied into things in the AI world, but it's incredibly important for a number of reasons. One of which is when you're capturing data in a user experience, the user experience kind of dictates how to capture quality data, right? So if you have a terrible user experience, most likely you're going to have terrible data coming into systems and therefore terrible data trying to train models. The other side of it is how to present the results of AI. So I'm sure everybody on the calls had an opportunity to see Netflix or Amazon recommendations, but these are all governed by models. And if those models don't have appropriate application in a user experience, they can confuse people. Likewise, as Tim mentioned around ethics, you got to think about the data you're collecting such that the models aren't heavily biased, and therefore when they get projected on a user experience, create problems. So again, product lifecycle, which includes product management and user experience, super critical to data maturity and AI strategy. Moving on to the next slide. This is what we tend to think about a lot around the technology side of AI, which is like having all the infrastructure, storage, technology platforms for data. Those things may be data lakes or analytics platforms, but also the people that are thinking about where to get data, right? So a lot of companies will think about data that they're collecting in their systems, maybe from their processes or with their customers. But the people that are really thinking about data as a product are thinking about third-party data, be it data that they purchase or public data that they bring into their organization that they integrate with their existing data to make it even more valuable. So data infrastructure, again, is kind of that analytics platform, the data sourcing, and then kind of the infrastructure inside of the operations that allow you to collect and actually analyze data. And then the furthest rung out is AI, right? So all the AI and machine learning stuff that's out there, it's really kind of the edge of everything that needs to be done to be successful in this space. And that would include, things like using AI products. So Tim mentioned ChatGPT. Companies need to think about their data literacy and how they can use existing products off the shelf to make them more efficient. It's also about building products that use AI. So for companies that are in the technology space in particular, having the competencies and the processes around actually training models and integrating them into products that they're delivering to customers. And lastly, customizing AI products. There's a lot of things that exist out there in the ecosystem that just need to be customized and used for your particular business. So these three areas, super critical to take advantage of AI, but it really starts with that core around people, process, architecture, and governance. Now, when we think about AI strategy, it's really not a one and done thing. As Tim mentioned, things are moving incredibly fast. And, it's fine kind of back in the 90s, maybe the early 2000s to build a strategy that's 3 years long and then to come back and look at it 3 years later. But unfortunately, these days, if you do that, you're going to be way behind. And so one of the things we recommend all companies think about is how to iterate through a strategy in short kind of cycles, right? Kind of the shortest cycle recommended is a year. And we really encourage kind of quarterly reviews of your strategy. But this includes things like thinking about your business objectives, where you are in your current capabilities around data and AI, mapping out a plan on how to fill those gaps in your capabilities, but most importantly, to use the data and technology and people and process to build things that allow you to meet your business objectives. So it's great to have a strategy, but if it's not tied into things that you need to do as a business, it's going to fail. So everything that you do around maturing your business around data and AI really needs to ladder up to that business strategy or your business objectives. So Aaron, that's all I've got on strategy, kind of quick view, but pass it back to you.
Beautiful. Thank you for that. It helps us get a little bit of a baseline in terms of strategy and AI. So let's unpack it a little bit further. And my first question for you guys, and this is something I've done quite a bit of research on, but just kind of expanding off of the presentation that you guys just did, What is AI particularly good at? I hear it's good at making predictions, but man, I've seen it make some ridiculous mistakes. Tim, I love the fact that you say sometimes it's just talking and not thinking. What is it? What is the break this down for me, and what is it particularly good at, so we can think of it as a tool?
You want to start
So,
there?
yeah. I can take that. So, AI systems, and I'm going to leave LLMs on one side for the moment, are very good at making judgments that humans can make, given enough data. So one of the sweet spots, for example, where AI really shines in healthcare is AI systems for radiology. It turns out that the community has focused on that problem for a long time. There are massive data sets where you've got radiology images and then labels that human experts have provided. Is there a tumor or not? Where is the tumor? What kind of tumor is it, for example? And if you've got lots of data of that form, you can train up systems that are as good as humans are. So those kinds of focused tasks where it's making a decision, it's finding something, it's predicting something, and you've got lots of data, AI systems are great at. Also the case, kind of shockingly, that if you think more broadly about perceptual judgments, and this used to not be the case, but identifying things in images, summarizing text, AI systems these days are really good at that. What they're not good at is reasoning tasks largely. So old school AI, back when I was young, we used to sort of hand code knowledge and build expert systems and write rules, and we would like turn a reasoning engine, and they would do, like expert systems for medical diagnosis, for example. Actually, Mycin was the first big expert system that was diagnosing bacterial infections. Modern large language models, real bad at that.
So you mentioned AI in healthcare. That's largely what we're talking about here. We're hearing it as a buzzword so often, and sometimes I feel like it seems really legitimate, where AI is a great element there, where it can do the prediction that you're just talking about. Radiology, I think, is a great example, for instance. But where are we really? I mean, everyone says that this is going to be largely disruptive for healthcare. Where are we in this process in terms of transforming the way healthcare is run, or how physicians practice, or the efficiencies of our healthcare? Where are we, generally speaking, do you think?
So I can jump in there to start. So I would go back to, it's kind of a function of the data, right? And I think particularly here in the US, we've been challenged because there's been silos of data that haven't been aggregated into large enough sets to build powerful AI models. Now, with that said, I think that's changing rapidly, right? So even though with the advent of electronic medical records, it's put a lot of stress on the healthcare system, it's also allowing us to start aggregating data that wasn't in one place before. And so what we're seeing now is a transition from those radiology examples that Tim mentioned to more unstructured data sets that allow us to do powerful things across patients and cohorts of patients. But I have to say, several years ago, AlphaFold came out, and that was just completely transformational in the healthcare space. So it's really having an effect in all areas of healthcare now as people build comprehensive data sets. So I would expect things to continue evolving quickly, but we've got a regulated industry, which in some cases stifles innovation, at least the speed of innovation. But we're seeing it being applied to kind of every area of healthcare now: pharmaceuticals, pharmacies, providers, payers. Everybody's starting to use it to drive efficiency and find patterns that generate more productivity.
Yeah, so but just to add on to that, I think one of the biggest impediments to having AI help with innovation in healthcare and MedTech is the nature of the data. So I've got collaborations with doctors at the local medical school. And in one of those collaborations, literally how I had to work with them was I would write not Python code because I like to code in Python, but I had to write R code because that was the only thing they could run. And I would write my code and I would hand it to them. And then they would run the code on the data because I couldn't get access to the data. And it was, like I was back in high school writing COBOL programs on punch cards where you put the stack in, you'd send it away, an hour later you get a result back. And so that's hard, right? So I think that Stephen's point about getting access to large volumes of integrated data that you can run the algorithms on in the way that data scientists and machine learning practitioners work is going to be super important. And then also just being able to have high volume compute associated with it, right? So if the hospitals are managing it and they've got some old Windows 3.5 box connected up to it, and you got to run everything on that's going to be a hard thing to do. The other thing I would say is that just patient-facing applications are real hard. So I think that, for example, language models, as Stephen said, I think can help with a lot of efficiencies internally inside the operations in healthcare. But I'm not sure I would want a language model doing anything that had to do with my treatment, given what I know about their weaknesses.
Yeah. Let's dig a little deeper into that. Why not? What are the deficiencies here?
Well, okay. So the interesting thing about language models, so the reason there's so much buzz around it is because, I think I said this earlier, you got an internet connection, you can go talk to one of these things, right? You sign up for ChatGPT, you're online, you're chatting with it, and in sort of point cases, very useful. So I use it sometimes. I was trying to come up with an example to use in my machine learning class the other day, and I was like, whatever, I'll ask ChatGPT. And it gave me this wonderful example to use, right? I was like, that's amazing. But the problem is that they are sequence models, which means what you do is you say something to it, and then it just starts talking, right? So it's like you're having a conversation, you shut your brain down. And actually, I've done this in class where I'll be lecturing, somebody will ask me a question. I'll wake up a minute and a half later and have no idea how I got there, right? I don't know what I'm saying. I don't know if I'm answering the question or not. That is what a language model is all the time, right? It's just saying stuff and then it stops. They don't have any sort of internal mental scratch pad. They don't think about things and sort of reflect on what they're doing. And they have so many weaknesses. The more you use them, the more you realize that they're just indescribably dumb about some things. So, have you found that, Aaron? You play around with language models, right?
Yeah, a lot. It's funny you bring that up. I can think of several different examples where we've tried to use it for different things, and it's amazing how dumb it is, like you said, right? And I think what you said is spot on, which is it's not specifically thinking about the implications. It's just making these connections that the neural network made because of the data.
Right.
So I think that's really interesting. Oh,
sorry, I was just going to give you an example. So I've been playing around lately with getting language models to add numbers. And I did an example where I was like, here's two big numbers, add them together, and it gives me the answer. And I go, well, here's a way to check your answer. Subtract one of the numbers from your answer and see if you get the second number. And if you don't, your answer is wrong. And it goes, oh, I did that. I see my answer is wrong. Let me recompute that. Here's the correct answer, which was exactly the first answer that it gave me that was wrong, right? And so you just never do that. There's no, again, it's like a person would never do that. And when it does that kind of thing, it makes you realize that there's something very different going on under the hood.
So I'll speak on the other side of the camp for a second, where I am completely excited about the application is really in the area of summarization, right? So a lot of what I do is take a bunch of information and try to process it quickly down into a few things. And that's been super, super helpful. But I've had, more query related interactions with large language models that just go off on very strange tangents, like squid beaks and giant squids and all sorts of weird stuff. And so I'm finding it really productive from a summarization perspective, like taking a large chunk of text and bringing it down to a level that I can work with. Because as Tim knows, like I can't personally process large amounts of text. I'm moving around too much. And so that summarization level stuff is helpful. But going back to healthcare, I'm just scared out of my mind that like something like this could diagnose me. I just don't trust it. And I feel like getting that right is really, really important. And there's a reason why we have checks and balances in the healthcare system with humans involved, because that's a really sensitive topic.
Yeah. There's the term hallucinations bounce around, right? And I feel like I experienced that for the first time last week, where we do a lot of intelligence. And so we use ChatGPT to help, make us smarter and learn things really quick and pull some information out. The questions that we're being asked by our clients, ChatGPT can't answer, at all. In fact, I tested it one time with a question and asked it a specific question that our client was asking us, and it gave me this beautiful answer, and I was floored. I was like, it was the first time it actually gave me something really, really meaningful. And I think this one was Bard that we were working with at the time, and Bard, Google's Bard, not Bard BD. And I said, what are the sources for that? And it gave me these beautiful, perfect sources, page, title, author, everything. And they didn't exist at all. And so I couldn't find them anywhere. PubMed didn't have them. Nobody had them. So I went back to the model and said, hey, these sources don't exist. And like 5 minutes later, back and forth, it finally said, oh yeah, you're right. We can't find it either. And so I was like, wow, that is scary.
Yeah, your references, right? It's like, don't trust it.
Right. So how do we overcome these deficiencies? Because I think a lot of people believe that, in some areas it's a saving grace for, running large statistical models on a ton of data. There's a ton of data in healthcare, right? For consumers, for diagnostics, for physicians. How do we overcome these deficiencies, and where is it going to be best used?
Go ahead.
On that one too.
Sure. Well, okay, yeah. So I got too many things going on in my head. So one thing, LLMs, wonderful, but there are tons of other machine learning technologies, right? So you don't want to throw out the baby with the bathwater. So lots of old school techniques. And actually, when we do consulting, I'm often saying, well, like you could do it with a language model, but maybe we could do it with a simpler thing that would be more powerful and give you better results. So, always keep that in mind. It's also the case, though, that there's an approach these days called retrieval augmented generation, or RAG. And the idea is what you do is you have your own content. And so, I don't know, you're practicing in a certain area of medicine and you've got a bunch of content about that area and you have a question, right? So I have a patient presenting in a certain way. What could be going on with them? And instead of the language model basing its answer on everything it read on the internet, you say, hey, you got to go look at this content that I gave you, find what you think is relevant and show it to me. Now, the interesting thing is it's limited, right? So if you trust that content, then largely you can trust the answers it give you. But you get the power of the language model because it can do the things like Stephen was saying, it can summarize it. So yeah, hey, I sort of found these 5 recent PubMed research papers that I think are relevant. Here's the high level gloss as to what's going on. Then you can engage in the back and forth and say, oh, well, tell me, more about this paper. And if you want to, you can go read the paper. So I think sort of establishing guardrails like that and not counting on the model just to know everything and do a good job across all domains, but backing it up with your own content is an important aspect of it.
I think that's part of the danger of getting too tied into the buzz, is there is like a longer tail of making these things work for your business or for your products. And that longer tail tends to have to do with people and process, not about technology as much. And so, we're starting to step into the area of fine-tuning large language models for our clients. And I think the hardest part is for them to understand that it's not plug and play. You don't take ChatGPT, put your data on it, it's ready to go, and now it can talk to your customers and everything it says is correct, right? There's a lot of feedback loops that need to happen. And we really advise them to kind of start by using it internally. That's really, really important before you start exposing these things to customers.
Yeah, to both those points, we do a lot of research internally on clinical data, clinical value, and so we're pouring through tons of peer-reviewed articles, right? And even then, with ChatGPT's new GPTs that you can build, right, and feed it specific information, and it utilizes it and the internet and its prior learning. I'll feed it. I think I fed it a dozen peer-reviewed articles the other day, and it still could not read through that and pull out the data that I needed it to. And so that those peer review articles are a huge portion of how we're running healthcare these days. And so I think that's an element that we have a ways to go on.
Yeah, I think just my experience has been, if I'm talking to a human, I tend to pack a lot into a question, right? So, you could say, "Hey, Tim, read this article and tell me what the primary hypothesis is, and was it verified or not?" Right? Language models can't do that. That's too hard. And again, I think it's largely because it's trying to go from a big blob of text to an answer. And so there are methods, like there's this chain of thought method, which is essentially ask it a chunk, right? Get it to figure out part of it and then keep asking it more questions. And so they tend, in my experience, you kind of have to lead them by the hand down the path, right? Which is annoying, because if I'm doing that, I might as well do the work myself, right? But so you have to be super careful with them about how you say things and how you frame the prompts. And again, that's a weakness that hopefully will be dealt with sometime soon.
Aaron, just out of curiosity, are you seeing a lot of MedTech, HealthTech companies excited about large language models? Like generative AI, is that becoming a buzzword in your space?
Yeah, 100%. And we're seeing more and more people saying that their technology has, the AI, but they don't have the data to actually build it from what we're seeing. And so it's this weird thing of people are riding this wave of buzzwords, but aren't actually delivering on it quite yet, because I don't think they have the fundamentals of the data and exactly what the AI is doing for them in that specific scenario. I mean, all the work that we do is based off of understanding the problems and the needs in the market, right? And sometimes those problems and needs don't even align to a large language model, for instance. So
that actually brings up a point. So for companies that are in the early stage, if they have an opportunity to kind of think about the data they will be collecting and the leverage they'll get out of that data, they can put some of that structure in place early and the governance around it to leverage that asset.
Yeah, that's a good point. Well, so let's go down this road a little bit further of being a disruptive technology, and the fact that Tim, you mentioned that we're crossing a chasm at this point, where it's becoming mainstream and useful in a lot of different ways. That makes me think about past technologies, and I'll just bring up an easy one. The iPhone, for instance, was this platform of a technology that enabled us to be wildly more efficient in everything that we did. And it feels like AI, in a way, is kind of the new platform moving forward. And so how is this scenario similar or different to disruptive technologies that we've seen in the past?
Steven, you want to do that, or you want me to?
I think he directed to you, but I'm happy to chime in there. It's an exciting topic for me. So Aaron, yeah, I mean, I was recently, I had started a company right before the mobile app craze, right, with Apple. In fact, Tim joined me in that company 2 years later. And so we were racing to build kind of one of the first apps in the App Store, and it was really exciting. And that platform obviously has made Apple and Google a tremendous amount of money. nowadays, I think the paradigm has shifted significantly with AI. It's not about kind of this two-dimensional app store anymore. I think it's more about how does this technology become integrated or interwoven into everything that we do. Again, today we're kind of interacting with AI through our desktop browser, right? But technologies like Humane and their Pin AI that just recently came out, they're giving us a glimpse of where this is going. I once read a science fiction series called the Gateway series, and the main character has an AI called Sigmund Freud, who's a three-dimensional hologram that's also in his ear. And that character becomes Albert Einstein and all these geniuses that's always with him wherever he goes. I think that's where we're going ultimately, that the App Store is a very kind of two-dimensional way of connecting to things you need to do. And the future is completely integrated into our experience and every day. Feels scary to me, honestly, but I think in the next couple generations, it's not going to be downloading an AI app. It's going to be having something that's working with you to get things done, that can take on many different personalities in many different channels.
Yeah, I mean, it's interesting. So you're right. You can look back through history and there are lots of technologies that are disruptive. I mean, even like just the advent of the industrial age changed things. Like, I guess I would claim that there's probably no technology more disruptive than a thing that's intelligent like a human that you can just have helping you all the time, that also knows a ton about everything, right? And so I think this is the most disruptive of technologies. The App Store analogy is interesting because as like I've got, there are too many. I use the weather app. Waze has changed my life, right? Because it makes my life better because I'm not sitting in traffic all the time. And I think what's going on in AI now is it's maybe like the early days of the iPhone, where like everybody's creating an apps, and you get one and you throw it away a day later, and then there are a few that are going to be super sticky. And so I think there's a lot of low-hanging fruit. People are having lots of interesting ideas, and lots of people are having the same interesting ideas. And what's going to happen is there's just going to have to be this kind of shaking out process where I think some of the applications are going to be really impactful and transformative, and then some are just going to kind of fall away.
Yeah, that's a great point. You guys work with a lot of executives, coming to you with trying to solve different things. What are you seeing from a healthcare and medtech perspective? Executives come to you for what problems are they trying to solve? What are they trying to approach with AI these days?
So the use cases are pretty broad. That's what's so exciting about being consultants, is we get to kind of jump into lots of different problems and help solve them. I would say initially they're coming to us with a use case and hopefully a good data set to fulfill that use case. But 9 times out of 10, we find that they have a lot more work to do on their data in order to have the outcome that they expect. More recently, and I think this is coming out of the back end of ChatGPT, they're coming to us about how do we devise a strategy around this, right? So they're stepping back and realizing we need to be more deliberate about what we're going to do. And many of them have learned just kind of through the hard knock ways that they can waste a lot of money and get nowhere, right? So having a strategy in place is really important. So strategy and kind of feasibility studies are the 2 things that we're seeing the most of.
Good. I want to go back real quick to the element, Tim, that you were talking about where, and Stephen, you mentioned having this integrated in us somehow, shape, or form in the future, right? Where it just becomes a part of our everyday life. And Tim, you're talking about the efficiencies that it helps us do. The App Store, I think, is a good example of that. What do you guys see down the pipeline in terms of clinical practice and healthcare and medical technologies? How, on one front, it can be scary. We already talked about the deficiencies and hallucinations that it has currently. But what is this going to do for clinicians? Is it going to replace clinicians, for instance? Is it going to supplement clinicians and make them wildly more efficient? Is it going to be more on the consumer side? Where do you see specific applications for it?
Yeah, Yeah. I mean, I think done right, there could be a boon for individuals, right? So if I think about the way I interact with the healthcare system, I've got a practice that I go to. I see a physician's assistant who happens to be wonderful, but she sort of works under the supervision of a doctor. I can imagine that you can, despite the fact that I don't want them diagnosing me, I said that earlier, that you can have individuals that are interacting with language models that have been trained up specifically for healthcare to deal with certain kinds of conditions and have certain kinds of knowledge, that could be a great triage, right? And so the important thing, I think, though, is having the human in the loop. So maybe my wonderful physician's assistant sits on top of some of these things, and people are having conversations with the language models, and she's kind of signing off on the work that they do in the same way that the doctor above her signs off on the work that she does. So because I found that I've tried to diagnose myself all the time from the internet, and I'm always wrong. I go to the doctor and I say, hey, I went to the doctor one time, I was like, I got a torn meniscus, and he's like, no, you don't. So so to the extent that we could do that kind of thing, I think that would be great. But then also, again, all the sort of efficiencies that we've talked about in terms of doctors quickly being able to ask questions of large volumes of information, that kind of thing could be really useful.
Well, yeah, because GPT recently passed the medical licensing exam with flying colors, and so it can stay up on a lot of this information that physicians do by going to and having CME credits, for instance, and things like that. So I see it really a really good support tool. But Stephen, what's your thoughts?
Yeah, I was just going to double click on Tim's point. What I'm hoping, and what I think is starting to happen, we've been on a couple projects in this space, is where the doctor has access to a machine that helps them identify patterns across specialties. So in particular, in the area of chronic illness or rare diseases, right? Just the typical doctor doesn't have the depth across all these disciplines, nor the data on the entire medical history of an individual or a group of individuals that share common themes. That's where I'm hoping clinicians get their superpowers from the data and AI, not to replace them, but to give them analytical tools that remove them from having to enter a tremendous amount of data and instead gather insightful data for them to make a strong diagnosis.
Yeah. Great points there. Okay, so for our audience, we're going to move into Q&A here in just a few minutes. And so if you have any questions, feel free to pop them into that Q&A box for us. But Stephen and Tim, just a couple more questions from my perspective. Is crystal ball here, what should we be looking for? How should we be directing these executives on how to best utilize AI for MedTech development, internal operations, health tech development, how do we best go about that, given the fact that we are on the frontier of this disruptive technology at this point?
So my suggestion is start where the data is. So if there are existing data sets out there that you can get access to that others can't, like that's the beginning of your moat. Or if you can start developing data that becomes your moat, like that's a great place to start. Just a suggestion there, if the audience hasn't taken a look at Truveta, I think it's a really interesting substrate to start MedTech, HealthTech type companies, because they've aggregated data across medical records from, I think, 12 different systems in the US. And that didn't exist a few years ago, right? I think it's 100 million patient records. That's a great substrate to think about how to build a moat around your data. There's data out there to start building that moat.
Yeah, Truveta, just to build off of that real quick, I think they've contracted with what represents 100 million patients in the US and all of their cross-talking EHR data. And so it's pretty interesting the way that they're monetizing that for hospitals, because they haven't been able to do it on their own in the past. Mayo Clinic is doing something similar with Mayo Clinic platform, and they have relationships with, I believe it's Duke and several other, high institutions. And so that's a great point. That getting that data out has been a struggle in the past. Yep.
Yeah, I mean, I was going to say, I think Stephen's point is a really good one. I find that when we talk to executives, they tend to have good intuitions about, I've got this data, I think it has this value, I think AI can help me. They're often very right about those things. They just need help sort of figuring out how to connect those two things together. But then the other element of it is just the classic old, where are my pain points? So is there some element of my process that's getting bogged down? Does it seem like AI is an effective tool for that kind of thing? So I think going from the data, from the pain point side, AI is a very powerful, flexible tool, but at the end of the day, it's a tool, and you're trying to make your pain points go away. That's one way to think about it.
Absolutely. Super interesting. All right. Question from the audience here for you guys is, what are the best practices for educating executives, particularly non-technical executives, which I think we see a lot, right? And leadership teams on how to use AI, and specifically in regards to how AI can help them be more productive, creative, or strategic. How do we educate these executives?
Yeah, so I think the great part of AI is there's a ton of information out there. The bad part about AI is there's a ton of information out there. So what we've found most helpful in this area is to actually spend time with executives and have use cases and examples that make sense to their business, right? So connecting AI to things that they understand is really important, and not going too deep into the technical weeds, right? I think there's a certain level that makes sense for executives. By the way, we educate folks in construction and legal and healthcare, and most of them have very little knowledge of technology, but they've all used ChatGPT now, right? So yeah. The exciting part is they're interacting with it. They may not realize how it works, but more importantly, how it applies to their business. That requires a personalized approach to education. That's not go read this course online, unfortunately.
Right. And that's sort of art of the possible. I think, as Stephen said, if it's driven by use cases, and then we start talking about AI, and, here are some of the kinds of things that you can do, here are the approaches you can take. I think then they start thinking and get excited about, now I see how this works. I can think about other applications to my particular problem space.
Yeah. Yeah. Another question around governance, regulatory type of things. How do we? The question reads, how can you discuss the current regulatory landscape for AI in healthcare, and how should companies be navigating these regulations? And I would add to that, the governance of these models. They can be wrong, and so how do we have the right regulations on that?
I don't know. That's hard. So let me just talk in general terms, and then we'll see if we can bring it back to healthcare. But the problem is that the models are already so powerful that, you got high school kids that are grabbing models from this open source places like Hugging Face, creating deep fakes. So easy to do these days. There's also a strong business motive for kind of pushing the envelope. So I think regulating these things is very difficult. I think that probably what needs to happen is that individual institutions are going to have to take the lead. So, so for example, I've got a language model. I fine-tuned it on my internal data. It knows everything about my health history. How do I know it's not going to start blabbing my health history to some other doctor who isn't treating me, and that information gets out? So, it seems to me that people or organizations need to think about what are the risks. Let's think about them. Let's assess them and figure out how we can deal with them internally. I'm just not real optimistic about coming up with any meaningful regulation above the level of an organization. I don't know how you guys feel. Aaron, Stephen, how do you guys feel about that?
I'll let that one go back to Aaron.
Yeah. I think it's really tough. And the first thing that comes to mind for me is, how do you retrain a model that has known deficiencies? I mean, your example of the math problem, right? Where you literally told it it was wrong. Here's the right way to think about it, and it still couldn't switch back. And in my simple mind, that's because the network that it's already created in the background is so strong that it can't overcome that. And I don't know if that's true or not, but so the first thing comes to mind is, how do we retrain a model or correctly train a model? When we found that it's wrong, and maybe that's the element that gets regulated. I don't know.
Yeah, I think the tough part is what is wrong. I mean, if there's factual outputs, that's one thing, but there's opinionated outputs. Like, how do you determine what's wrong? I also am kind of concerned, globally about it, right? So if we overregulate here, what does that mean to the rest of the world? I think it gets really complicated quickly.
Yeah.
Yeah, great point. One more question here. What do you think is the role of synthetic data generation tools industry to fill the data and availability gap due to compliance, privacy laws, et cetera?
Yeah, that's a really good point. And I know that there are companies out there that their business model is, hey, give us some real data. And then what we'll do is we'll sort of learn about the distributions and the patterns in it and generate synthetic data for you. So I think it's viable and is a good idea. And in fact, synthetic data is used all the time in training neural networks. It's called data augmentation, but trying to create synthetic data that makes the model robust with respect to variation that it might see when it's applied in actual problem domains. You just have to be careful that the synthetic data actually has a distribution that looks a lot like the data that you care about. So it's tricky, but I think it's an important tool, especially in an industry that's regulated as heavily as medicine and healthcare is.
Interesting. Good. Well, good. Well, we're up against time, guys. Any closing thoughts as we close up here?
Well, I'll just say that, you picked a topic area that is going through a lot of change and excitement and fear. So really appreciate you kind of teeing this up. And we're really focused on making sure that humans are part of the equation in everything that we do. And we think healthcare is just such a great environment to, explore the use of these technologies and help people.
Yeah. Absolutely agree. Stephen, Tim, thank you for enlightening us today. We truly appreciate it. For the questions we didn't get to, or anyone on the webinar, feel free to reach out to Tim and Stephen. I know they're very approachable, and we'd love to continue to unpack this and watch this frontier move forward in a really interesting way. We're super excited about this. So thank you guys for your time today.
Yep. Thanks, Aaron.
Thanks for having us, Aaron.